Hello, everyone. In this session, we will explore how to use Codelab to create interactive behaviors for the robot. In this course, we will start with an introduction, followed by architecture and interface explanations, a practical demonstration, and finally an introduction to mission cards. Chapter 1, Introduction. Codelab is a tool that allows users to create custom programs for Kebbi through simple block dragging commands. No complex coding or software installation needed. With AI blocks, you can elevate interactivity, while the 3D simulator provides real-time preview. Additionally, Codelab supports IoT protocols, enabling cross-device control. First of all, enter the official website of NUA. Click on the character icon at the top right to log into your NUA account. After logging in, please check the authorization status of the robot in the Biz authorization in My Device. Click on My Tool or the list icon at the top right to find Codelab. Then you will enter the homepage of Codelab. Chapter 2, Architecture and Interface. Regarding the operation process, we start by creating a new project on the website, then edit content and deploy it to the robot. After deployment, open the Codelab app on the robot and select the project to begin the interaction. Alternatively, the robot can be awakened and commanded to start the project using the magic words. Upon entering the website, you will start in the project list, with the option to switch to mission list in the sidebar. We'll cover mission cards later in the session. The project section is primarily divided into two pages, the project list and the editing page. The project list displays all your projects and allows you to deploy to robots, upload, download, set sharing options, move projects, set project properties, export or delete projects. You can also create new projects here. Start by clicking Create and selecting Create Project. Alternatively, you can select from existing templates. Next, enter your desired project name and optionally magic words to unlock the project. You can choose between two formats. 1. Programming Project, MBKX, ideal for complex programming logic, offering the most comprehensive blocks available. 2. Script Project, coding, suitable for one-time executions, reverting the robot to its default state after playback. Note that only coding format can be imported into raw flow. After creating the new project, you'll enter the editing screen. This screen is divided into 5 main areas. The block directory on the left expands upon clicking a category, allowing you to drag blocks onto the canvas. The top left displays project settings, while simulator playback and device connection buttons are on the top right. Editing tools are in the lower right of the canvas, and the 3D simulator is on the far right. Program blocks fall into 3 main categories: AI induction, motion, and math and logic. AI induction blocks are used to define flow initiation conditions and control multiple sensors, such as facial recognition, object recognition, touch, and sound detection. Action blocks display the robot's capabilities, including movement, expressions, visuals, lights, and sounds. These can be integrated with pre-existing assets from NUA's library. Math and logic blocks handle calculations and logic settings, such as loops, functions, formulas, text, and lists, allowing for complex interactive effects. In addition to the 3 main block types, you can add extension blocks by clicking Edit Extensions at the bottom of the block directory. There are 4 main types of extension blocks: OpenAI, Teachable Machine, AI Training School, and IoT. OpenAI block connects the robot to the OpenAI server, enabling multi-turn conversation capabilities and computation functions. Teachable Machine block, developed by Google. Teachable Machine is an open-source tool that enables object training through a computer's camera without programming experience. This block imports Teachable Machine-trained AI models into Codelab, allowing object recognition via the robot's camera. AI Training School block, created by NUA, this app enables direct photo training on the robot for object recognition models. The AI Training School block imports these trained models into Codelab for the robot's camera to perform object recognition. IoT block. Once connected to an IoT server, this block enables control and communication through the MQTT protocol. Now that we have covered the basic concepts, let's put them into practice. Use Codelab to build an interactive project where the robot assists you in choosing a meal. First, let's watch a demonstration video of the final outcome.
Can't think of what to eat? Touch my belly, let me tell you. Ramen. Beef noodles.
Next, we will proceed with the operations on the web interface, as shown in the demonstration video. It is recommended to pause the video first, try to follow the steps on your own, and then refer back to the example video once completed. To begin, go to Project List, create a new project, and enter a project name. You can set magic words if desired, select a file format, and adjust privacy settings. After saving, you'll be directed to the editing screen. Once in the editing screen, locate the sound block from the block directory and set the robot to speak a specific phrase. Use the control block to manage execution. To implement random actions, set a variable and randomly assign values from 1 to 100. Divide the variable into 4 ranges of 25, creating 4 options. For each option, you can use the face block and image upload block to display an image, enriching the interaction. Repeat these steps for 3 more options and you're done. Once editing is complete, remember to save. Then click Play on Simulator in the top right corner. During playback, each block on the canvas will highlight, indicating the current action. While testing, use the Simulate Touch button in the 3D simulator to activate robot responses. Finally, click Connect to Device in the upper right corner and select the robot to connect. Choose Robot as the playback device and click Play. Once the file is deployed, the selected robot will automatically enter Codelab and run the project. To manually open the project on the robot, go to the project list in the previous page, select the project, and deploy it to the robot. After completing the website settings, let's explore how to proceed on the robot side. In the main menu, open the Codelab app, select the project to execute, and the robot will begin the demonstration. Having mastered the basics, let's move on to mission cards, which help you combine blocks to complete fun challenges. As mentioned at the beginning, you can switch to mission list from the sidebar. In the mission section, you'll find multiple levels, and the top of the page provides quick access to switch between chapters. Click on a mission to start the challenge. Upon opening a mission, you'll see a mission description on the right side. Follow the instructions to complete the assignment, then send your answer to review your results. Congratulations on learning the Codelab. For more tutorials, please scan the QR code to continue learning at the newest support.